Chapter 6.1, Ratios, Proportions, and the Geometric Mean. If A and B are two numbers or quantities and B is not equal to 0, then the ratio of A to B is A over B. Okay, and the ratio can also be written like so. Okay, so the fraction here is the equivalent of this right here. All right, the ratio of a side length in triangle ABC to a side length in triangle DEF can be written as 2/1 or 2:1. Okay, so here is triangle ABC. All of the side lengths are 2 meters. Here's triangle DEF. All of the side lengths are 1 meter. So the ratio of the side lengths is just going to be 2/1. Ratios are usually expressed in simplest form. Two ratios that have the same simplified form are called equivalent ratios. So 7:14 and 1:2 in the example below are equivalent. All right. So before I even look at the diagram, all they did here was reduce this fraction. Okay, if you take 7/14, dividing the top by 7, that's 1, and dividing the bottom by 7, that's 2. So that's all they did here is reduce the fractions. Okay, if you take the width of RSTU, that's right here at 7, and the length of RSTU is 14. So it's just 7/14. All right, and typically you want to have the units match so that you can cancel the units as well. Okay, example 1, simplify the ratio, 64 meters to 6 meters. So I am going to write this in the form of a fraction. Okay, so 64 meters divided by 6 meters. Okay, meters over meters cancels. And these are both even numbers. Okay, so I'm going to divide the top and bottom by the same number. 64 divided by 2 is 32. And 6 divided by 2 is 3. Final answer. Okay, and they got the same thing. You can write it as the fraction or like so. Okay, part B, the units here do not match. So you need to convert the units. All right, we know that 1 foot is the equivalent of 12 inches. Okay, so I am going to multiply the top by 12. All right, really, if you want to get technical, you're really supposed to do it this way. You're supposed to multiply by 1 over the other. So it would be 12 inches over 1 foot. Okay, so same thing really. So feet divided by feet cancel, and inches divided by inches cancel. Okay, and then you have 5 times 12 is 60. And then you just have 20 times 1 is 20. Okay, 60 divided by 20 is 3. But you want it in the form of a ratio. So we just put it over 1. It's still the same as 3. But we want it as a ratio. So it's 3/1. Okay, please pause and try guided practice number 1. So we have 24 yards. abbreviated YDS, divided by 3 yards. Okay, the units match, so we can cancel yards. And of course, 24 divided by 3 is just 8. But we want it as a ratio. So I'm going to make it 8 over 1. Okay, it's still equivalent to 8, but it's in the form of a ratio. Please pause and try guided practice number 2, and I'll give you a hint. 100 centimeters equals 1 meter. So you're going to have to convert the meters. Okay, so we have 150 centimeters over 6 meters. All right, and of course we can just multiply the 6 times 100. All right, but I want to do it properly. So when you have two things that are equivalent, you can just multiply by one over the other. All right, and since I want centimeters to cancel, and I have centimeters on top, on my next fraction, I want centimeters on the bottom. All right, this way it will cancel top and bottom. All right, so 100 centimeters equals 1 meter. I'll put 100 centimeters on the bottom and 1 meter on the top. All right, and now centimeters and centimeters cancel. Meters divided by meters cancel. 150 times 1 is 150. 6 times 100 is 600. Okay. Dividing top and bottom by 10, we just eliminate a 0. 150 divided by 10 is 15. 600 divided by 10 is 60. Okay, and we can still reduce this further because 15 divided by 15 is just 1. And 60 divided by 15 is just 4. Final answer. Example 2, you are planning to paint a mural on a rectangular wall. You know that the perimeter of the wall is 484 feet, and the ratio of its length to its width is 9:2. Find the area of the wall. So it was given that the ratio of the length to the width was 9:2. All right, and you can adjust any ratio by multiplying the top and bottom by x. Okay, so I'm going to multiply this fraction by x over x. Okay, it's the same thing as multiplying by 1. That's why I'm allowed to do that. So 9 times x is going to be 9x, and 2 times x is going to be 2x. All right, so this 9x is going to be the length, and the 2x is going to be the width. Okay, the reason I am using x is because we don't know the actual length and width. Okay, we just know the ratio of the length to the width. So 9 over 2 is the same as 9x over 2x. I did not change the ratio. So it said that the mural was rectangular. It was a rectangular wall. All right, so we made the width equal to 2x, and we made the length equal to 9x, and it was given that the perimeter was 484. Okay, how do you find the perimeter of a rectangle? You just add up the sides. All right, so if this side is 2x, this side is also 2x, and if this side is 9x, this side is also 9x. Really, you don't need to write that in because it's a rectangle. Okay, and the formula for the perimeter of a rectangle is just 2 times the base plus 2 times the height. Okay? Or we did length and width. So instead of base and height, I'll make it length and width. Same thing though. 2 times the length plus 2 times the width. All right. We said the length was 9x. And we said the width was 2x. So that's going to be 18x plus 4x, which is 22x. Okay, that's the same thing as if we just added all 4 sides. 9 plus 2 plus 9 plus 2. You would just get 22x. All right, and that equals the perimeter, P. But we said in the problem, the perimeter is 484. So in place of P, I'm just going to plug in 484. And now solving for x, we divide both sides by 22. Okay, 484 over 22. On the calculator, I get x equals 22. Okay, now that's not quite what they asked. They wanted to know the area of the wall. All right, so let's see. X is 22. So now we have, do it in a different color here. We have the length equal to 9x. But x is 22. So that's just 9 times 22. And that equals 198. Okay, and the width is 2x. So that's going to be 2 times 22, which is just 44. Okay, now the units for the perimeter were in feet. Okay, so these are both going to be in feet. All right, and finally, for the area, we know the area of a rectangle is just length times width. So that's going to be 198 times 44. On the calculator, I get 8712. All right, and since we did feet times feet, the units are going to be feet squared. Okay, so to sum it up, they gave us the ratio of 9:2, but we didn't know the actual length and the width. So we added an x on both the 9 and the 2. Okay, the ratio of 9 over 2 and 9x over 2x is still the same thing. They gave us the perimeter, so we plugged in 9x and 2x for the length and the width in the perimeter formula. Okay, and then solve for x. Once we solve for x, we were able to find the actual length and width, and then use those two values to find the area. Okay, example 3. The measures of the angles in triangle CDE are in the extended ratio of 1 to 2 to 3. Find the measures of the angles. All right, so for extended ratio, that just means that there's more than 2 numbers. Okay, so you're not going to be able to write it as a fraction. All right, but it's still the same thing. 1 to 2 to 3. Now, just like we said before, you can multiply each of these terms by x and it won't change the ratio. All right, so we can make this ratio 1x to 2x to 3x. And it's still the same thing. All right, so this ratio here was the ratio of the angles. All right, it says the measures of the angles are in the extended ratio of 1 to 2 to 3. But we can't call the angles measurements 1, 2, and 3. We're going to call the angle measurements 1x, 2x, and 3x. All right, so that's what they did here. This angle here is x, this one is 3x, and this one is 2x. We know that the angles inside of a triangle add to 180, okay? So all we have to do is add the three angles and set them equal to 180. So we have x plus 2x plus 3x equals 180. Okay, x is the same as 1x. 1 plus 2 plus 3 is 6. And that equals 180. And dividing both sides by 6, x is just 30. All right. And of course, in order to find each angle, you want to take the 30 and plug it in. So x right here is just 30. And if you plug in a 3 right here, 30 right there, 3 times 30 is 90. And if you plug in the 30 right there, 2 times 30 is 60. Okay, does your answer make sense? Well, 30 plus 60 plus 90 equals 180. And that's what we wanted. So it checks out. Okay, please pause and try guided practice number 3. All right, number 3. It says the perimeter of a room is 48 feet. The ratio of its length to width is 7 to 5. Find the length and width of the room. All right, let's see here. It says the length to the width is 7 to 5. Okay, so I'm just going to write it as L over W. So that ratio is 7 to 5. Okay, remember we can multiply top and bottom by x without changing the actual ratio. Okay, so my length is going to be 7x and my width is going to be 5x. All right, so that's the length. And that's the width. All right. And now it said the perimeter is 48 feet. It's a room, so I'm going to assume it's a rectangle. Okay, so the perimeter for a rectangle, just like we did before, that's 2 times the length plus 2 times the width. Okay, if you recall, the opposite sides of a rectangle are congruent, right? So that's why we're going to do 2 times the width and 2 times the length, all right? So 2 times the length is 2 times 7x. And 2 times the width is 2 times 5x. All right, so that's going to be 14x plus 10x. That's 24x. Now that equals the perimeter, P. But it was given in the problem, the perimeter is 48 feet. Okay, not sure what happened here. The perimeter is 48 feet. So in place of P, I'm going to plug in 48. Solving for x, I'm dividing both sides by 24. 48 divided by 24 is 2. Okay, now we're in business. X equals 2. So therefore, the length, which we said was 7x, is just 7 times 2. And the width we said was 5x, is just 5 times 2. All right. And the perimeter was given in feet. So both of these are going to be in feet. Okay, please pause and try guided practice number 4. It says a triangle's angle measures are in the extended ratio of 1 to 3 to 5. Find the measures of the angles. I'll give you a hint. You want to make it 1x, 3x, and 5x. Okay, so the ratio of the angles is 1 to 3 to 5. If you multiply each one by x, that's going to be 1x, 3x, and 5x. Okay, that does not change the ratio. It's still the same thing. All right, so as you know, the 3 interior angles of a triangle, they add up to 180 degrees. So we just add the 3 angles and set them equal to 180. All right, 1x plus 3x plus 5x is going to equal 180. Okay, adding these 3, that's going to be 9x. Equals 180, and dividing both sides by 9, x is 20. Okay, how do you find each angle now? You plug it in. All right, so the 1x is just 20, and the 5x is going to be 5 times 20, which is 100. And the 3x is going to be 3 times 20, which is 60. Okay, all I did was take x equals 20 and plug it in on each one. Does the answer make sense? 100 plus 60 plus 20 equals 180. So it checks out. Continuing, chapter 6.1. A proportion is an equation that states that 2 ratios are equal. All right, let's see here. So when you set up the proportion, the numbers on the top left and bottom right are considered the extremes, and the numbers on the bottom left and top right are considered the means. So this is the cross products property, okay? It's basically just cross multiplication. So all they did here, they multiplied bottom left times top right. That's 3 times 4. And they're just showing you it equals top left times bottom right. That's 2 times 6. All right, so if you have the proportions set equal to each other, this will always work. All right, example 4a, they want us to solve the proportion. I guess they mean solve for x. Okay, so we just cross multiply. Top times bottom is going to be 5 times 16. And that equals bottom times top, 10 times x. Okay, solving for x, we just divide both sides by 10. And you can use a calculator, but in some cases, it's easier to just cancel. Okay, of course, the 10s cancel here, but I know 10 divided by 5 is just 2. Okay, and 16 divided by 2 is just 8. So x equals 8. And part B, a little more work, but still the same thing. Okay, top times bottom is going to be 1 times 3y. Bottom times top, make sure you take the entire denominator. Okay, that's going to be y plus 1 times 2. All right, you have to use parentheses. All right, 1 times 3y, of course, is just 3y. On the right-hand side, you have to distribute. 2 times 1 is 2. 2 times y is positive 2y. Solving for y, we subtract 2y on both sides. 2y minus 2y is gone. 3y minus 2y is y. And of course, that equals 2. So if you have something added or subtracted in the numerator or denominator, make sure you use parentheses and the distributive property. All right, please pause and try problems 6 and 7 right here. All right, on number 6, top times bottom, 1 times 3x. Bottom times top, you have to use parentheses. Okay, so it's x minus 3 times 4. 1 times 3x is, of course, 3x. Distributing the 4, that'll be 4 times negative 3, or negative 12. And 4 times positive x. Okay. So I'm going to do minus 3x on both because I want the x's on one side. And I'm going to do plus 12 on both because I want the numbers on the other side. (3x minus 3x cancels. Bring down the equal sign. 12 minus 12 cancels. And 4x minus 3x is just x. All right, number 7, use parentheses. Okay, top times bottom, y minus 3 times 14. And then bottom times top is just 7 times y. All right, distributing the 14. 14 times negative 3 is negative 42. 14 times y is positive 14y. And 7 times y is 7y. All right, subtracting 14y from both sides. Bring down the negative 42. 14y minus 14y cancels. 7y minus 14y is negative 7y. All right, dividing both sides by negative 7. And of course, the negative 7s cancel. And negative 42 over negative 7 is going to be positive 6. Okay, remember that negative divided by negative is positive. All right. And of course, if you're not comfortable with that, you can always keep the y's negative. Okay. I could have done plus 42 on both sides and minus 7y on both sides, and I would have gotten 7y equals 42. I would have got the same answer. All right, example 5. As part of an environmental study, you need to estimate the number of trees in a 150-acre area. You count 270 trees in a 2-acre area, and you notice that the trees seem to be evenly distributed. Estimate the total number of trees. Okay? So there's 270 trees in a 2-acre area. All right? So we will put trees in the numerator and area or acres in the denominator. All right. And now we're going to set up a ratio and proportion. Okay. So there's 270 trees in 2 acres. So 270 trees for 2 acres. Okay. I lined it up. And then you want to do the next fraction the same way. Okay. The next fraction is 150 acres. And we don't know how many trees, okay? They want us to estimate the total number of trees. So we're just going to call that X, okay? Because they gave us how many trees are in 2 acres. I made a little mistake. Hold on. I made a little mistake. Okay, the numerators are supposed to be number of trees. That's why it's good to label it. So let's fix that. Okay, 270 trees in 2 acres. We have that. And now we have 150 acres. The acres goes in the denominators. And we want to estimate how many trees are in 150 acres. So we're just going to call that X. All right, and now we're in business. All right, cross multiplying. We have 2 times X. And that equals 270 times 150. All right, solving for X, you just divide both sides by 2. And I'm going to do this on the calculator. Okay, you can start doing it by hand. If you want to do 150 divided by 2, that's 75. Or you can just do the whole thing on the calculator. And using the calculator, I get 20,250. All right. And let's make sure that's what they got. Now, sometimes you can do this stuff in your head. Okay, I'll show you a little shortcut after you set up the ratio and proportion, what you could have done. Notice that to get from 2 to 150, it's times 75, right? You multiply by 75. So if you want to get from 270 to X, you can also just multiply by 75. All right? And that's basically what we wound up doing, 270 times 75. So if you can see how much of a multiple the other fraction is, you can take a shortcut instead of cross-multiplying. All right, and one other shortcut you could have done, since this is X over 150, you could have just multiplied both sides by 150. It cancels on the right. And X would just be this part right here. So lots of ways to do it. other than cross multiplying. Okay, here we have the geometric mean, and it's basically just the square root of the product. All right, so it says the geometric mean of two positive numbers a and b is the positive number x that satisfies this equation. All right, so they made it complicated here. So if you do x times x, you'll get x squared. If you do a times b, you'll get ab. And then take the square root of both sides, and you'll get x equals radical ab. The bottom line is the geometric mean is just the square root of the product. Okay, the product means you multiply the two numbers, and you know what square root is. Example 6, find the geometric mean of 24 and 48. All right, so there's going to be two main steps involved. You want to multiply and take the square root, and then simplify or factor. All right, so let's start with step 1, multiply and take the square root. We are going to start with 24 times 48. Okay, so you can use parentheses, or you can use the dot in between. Okay, and take the square root. All right, so let's break this up a little bit. We have the square root. What times what is 24? Well, let's start with 6 times 4. Okay, that's pretty good. And what times what is 48? Let's start with 6 times 8. Now, under the square root, whenever you have two numbers that repeat, that are multiplied, you cancel two of them and factor one of them outside of the square root. So the square root of 6 times 6, you cancel two of them. Square root of 6 times 6 is just 6. That's outside of the square root. The square root of 4 is just 2. So I'm going to take the square root of 4 and multiply 6 times 2. And now let's see, for the number 8, we can break that up. 8 is the same as 4 times 2. And the square root, this is all under the square root. The square root of 4 is just 2. So cancel the 4 and bring a 2 outside. Okay, whenever you bring the number outside, it's going to be multiplied by the other numbers. The only thing left under the square root is a 2. 6 times 2 is 12, times 2 is 24. And the only thing left under the square root is 2. So it's 24, radical 2. Okay, so you basically want to break up the numbers and look for repeats, or look for a number you can take the square root of, like the square root of 4 is just 2. Pause and try guided practice number 8. It says in example 5, suppose you count 390 trees in a 3-acre area, and then they want you to estimate how many trees are in a 150-acre area. So what you want to do is have trees in the numerators, and then you want to have acres in the denominators. Okay, for the new estimate for the total number of trees, I would just make that equal to x. All right, so do 390 over 3 equals 150 over x and solve it. All right, the number of trees, we had 390 trees in 3 acres. And then the new estimate for the number of trees we don't know, we can call it x. And how many acres are in the new estimate? That's 150. All right. To solve for x, the opposite of dividing by 150 is times 150. You could do it that way. I'll do it the basic way, cross multiply. Top times bottom is 390 times 150. All right, so this is cross multiplication. 390 times 150, and that's going to equal bottom times top, 3 times x. Solving for x, the opposite of times 3 is divided by 3. Do that to both sides. The 3's cancel. And here you can do this whole thing on the calculator, but I know 150 divided by 3 is just 50. And I'm still going to use, I'm still going to use the calculator here. 390 times 50. And I get 19,500. All right, and what are the units on that? Well, we said the numerator was the number of trees. Okay, so that's 19,500 trees. All right, like I said, since it's x divided by 150, you can do times 150 on both sides. You'll end up with the same thing. Okay, please pause and try number 9. They want us to find the geometric mean of the two numbers. So try number 9, please. All right, number 9 is 12 and 27. So we multiply 12 times 27. And take the square root. Okay. Now, in the example before, I used the factoring tree. You actually usually don't need to do that. Okay, but let's just start breaking these up without the factoring tree and see what happens. I know 12 is the same as 3 times 4. So that's a good start. And I know 27 is the same as 9 times 3. Now, we said if you have a repeat, you can scratch off cancel 2 and bring one of them outside. So the square root of 3 times 3 is just 3. Okay, you bring that outside of the square root. The square root of 4 is just 2. So we have 3 times 2. And the square root of 9 is just 3. So we canceled everything under the square root. 3 times 2 is 6, times 3 is 18. So that's for 12 and 27. All right, please try number 10. Number 10, let's see, we have 18 times 54. And you take the square root. Let's break them up a little bit and see what happens. 18 is the same as 9 times 2. 54 is the same as 9 times 6. All right, so we have two matching numbers under the square root, 9 times 9. Cancel 2 of them and bring one of them outside of the square root. All right, we have 2 times 6. Let's see. Maybe we can break up the 6. 2 is already a prime, but 6 is the same as 2 times 3. All right, now we have a repeat. 2 times 2. Cancel 2 of them and bring one of them outside of the square root. And the only thing left under the square root is just a 3. 9 times 2 is 18. Radical 3. All right, please pause and try number 11. I'll give you a hint. I would start by taking the square root of 16. That's pretty easy. All right, so we have 16 times 18. And we're taking the square root. Square root of 16 is just 4. And 18 is the same as 9 times 2. So we keep the 4 outside. Square root of 9 is just 3. And underneath the radical, the only thing left is a 2. All right, 4 times 3 is 12. And we're left with radical 2.